Hi, welcome to the Olympiad geometry. Let's continue our study on triangle incenters. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe the channel. Here is the problem. AO is the altitude of base side EF in an isosceles triangle AEF, and AO equals to EF. Extend AE to B so that BE equals to AE. BC is perpendicular with AF on C. Prove that O is in center of triangle ABC. This is a problem that has many solutions. I'll just show the ways that I think of. So the first time I met this problem, I was thinking, if we want to prove that O is in center of triangle ABC, we already know that AE equals to AF because triangle AEF is an isosceles triangle, right? We know that AE equals to AF. And we know that AO is the altitude on EF, which means AO is perpendicular with EF and EO equals to OF, right? O is the midpoint of EF, right? And we know that AO equals to EF, which means AO is twice of EF, right? AO is twice of EF. AO is twice of EO. AO is twice of EO, right? AO equals to EF. That's from the problem set. So that means the AO is angle bisector of angle BAC already. Right? AO is angle bisector of angle BAC already. So we just need to prove either BO is the angle bisector or CO is the angle bisector. Right? So we connect BO here. We just need to prove that BO is angle bisector or CO is angle bisector. Let's just consider about BO for now. If we want to prove that BO is an angle bisector, we need to prove that the angle EBO equals to angle OBC, right? So we want to find the relationship between this angle and this angle. Now let's set this as alpha and set this as beta. So we would see that it's easier to represent the angle later. Now we do parallel line through E. Okay, so through E, we do a parallel line that in parallel with AO, right? We do a line in parallel with AO that is through E and intersect BO on D. Okay, so this is point D. And we find the midpoint of AO. Midpoint of AO. Okay, midpoint of AO. And connect let's call that M. And connect EM. Okay? So we know that ED is in parallel with AO. Right? ED is in parallel with AO. And M is the midpoint of AO. So because ED is in parallel with AO, so we know that angle EDB equals to angle AM angle ED, because this in parallel with this one, so we know that angle EDB, this angle, equals to this angle, right? Equals to angle AOB. So this angle equals to this angle, right? And angle BED equals to angle BAO. Right? Angle BED, this one, equals to this one. Right? And because E is a midpoint of AB, so we know that ED and ED is in parallel with AO, so ED is half of AO, right? Which means if we find the midpoint of AO, that ED equals to MO, right? That is MO. And also, because E is a midpoint of AB, M is a midpoint of AO, so EM is in parallel with BO. So that angle AME equals to, I just write here, angle AME equals to angle AOB. Right, so equals to angle AME. So we know that this angle equals to this one equals to this one, right? So now we can just say that triangle AEM AEM and EBD are identical. So that is saying we know that these two triangles, right? We just find the relationship between these two triangles. Okay, now let's see. We know that ED equals to AM equals to MO, right? ED equals to AM equals to MO, and also equals to EO, right? Because AO is twice of EO. So half of the AO, that's MO, equals to EO equals to ED. And we know this is 90 degrees, so the angle EOB equals to 45 degrees. Right, EOB, this one is 45 degrees. Let's just, okay, this is EOB, that is 45 degrees, which means half of angle BAC plus ARF equals to 180 degrees minus 135 equals to 45 degrees. Right? This angle plus this angle equals to 180 minus 135, that is 45 degrees. So this plus this equals to 45 degrees. Right? And we also know that ARF plus half of angle BAC plus 135 degree, that is 180 degree, right, equals to alpha plus beta plus twice of angle, half of angle BAC, which is angle BAC plus 90 degree, right? So alpha plus beta plus angle BAC plus 90 degree, that's 180 degree, and this is 180 degree, right? Based on this, we can get that beta, see, alpha cancels, and beta equals to 45 degree minus half of angle BAC, right? And it equals to 45 minus half of angle BC, which is alpha, right? So beta equals to alpha, which means BO is an angle bisector of angle ABC. So O is the intersection point of BO and AO, which means that O is the incenter of triangle ABC. Right. So for this problem, it has many ways to do the proof. We can do things like this from the midpoint of AO and do a perpendicular line of AE and to calculate it. I wouldn't go that way because this is a way that first time I solve this problem, I think it's pretty simple and easy to think of. So for this problem, the issue or the breakpoint of this problem is that find a way to calculate alpha and beta, right? Find a way to calculate alpha and beta. And once we find the relation of alpha and beta, we easily prove that BO is the angle bisector of angle ABC, right? Okay, I hope you like this video and see you in next one. Thank you.